whole unit is on rocks and soil, so we're going to talk about the rock cycle. You have most of this written in your packet, but it involves the constant formation and destruction of rocks. So it's a cycle, just like the carbon cycle, the nitrogen cycle, the phosphorus cycle, all of those. So it is the slowest of all cycles, if we're talking about carbon or nitrogen, because it takes thousands of years for rock to form and for rock to be broken down. All right, you have this bottom one on the next page, so you don't need to write it. It involves all these different things that you just saw in the rock cycle. So weathering, erosion, melting, cooling, heating, pressure. And as you can see, like with the diagram or the diagram you looked at, every type of rock can become a different type of rock just through a certain process. So igneous rock, you can think of it as like ignite, right? So igneous rock comes from volcanoes, comes from magma. So formed from magma, either hardening, underground, or above ground. As a result, it's found in a lot of the crust because much of our crust was formed from magma cooling. Just like we talked about with seafloor spreading, that magma hardening under the ocean floor. Same thing happens when we get magma rising up to the surface and it is not in an ocean. So when we bring magma up to the surface of the earth, we're also bringing up minerals or metals or nutrients, just like how in the ocean we talked about how upwelling brings up nutrients as well. So examples here, granite, basalt. Don't spend time memorizing examples. I've never actually seen them. Quiz you on types of rock, so don't worry about that too much. But just so you have an idea, pumice, if you've ever heard of like the pumice stone that you use like in the shower or like on your feet, that is an igneous rock. So it's formed from magma cooling. And as you can see, there are different colors, different textures of rocks, and it depends on how fast they cool and whether they cool inside or outside of the earth. Sedimentary rock, so this is sediment, right? So it's formed from dirt, and typically it's formed when dirt is compressed. So you guys have all seen sandstone. This is a good example of a sedimentary rock. These hold the fossil record because what happens is when organisms get stuck in dirt and sand, what ultimately happens is sometimes, if the conditions are right, they can form fossils, right? Those casts or mold, and then we can find those fossils later on. And then we have metamorphic rock. So metamorphosis, that means like to morph is to change. So these are rocks that already exist, but they get changed because they're under heat and pressure. So metamorphic rocks can include slate or marble, quartzite. So igneous from magma, sedimentary from sediment, and metamorphic rock from pre-existing rocks. So the next thing, we're just going to talk about weathering, and then that'll be it for notes, and I will let you work on your vocab. I would like the first 2 pages, to the front and back of the first page, due by Friday, or on Friday. But in the 15 minutes that I gave my last class, like kids who worked on it got the first page done, as long as they were working on it like I'm not like doing other things. So the other thing I want to talk about is weathering, which you guys saw as part of the rock cycle. This is how soil forms, right? Is soil forms from organic matter, right? So stuff that used to be alive decomposing, and also from fragments of rock, okay? And so weathering is breaking down rocks and eventually forming soil. So we have two types of weathering, just like chemical reactions, we have, or changes, we have physical change and chemical change. We have physical weathering and chemical weathering. Physical weathering is literally if we just take the rocks and we break them apart just using force, whether it's the force of wind or water or plant roots. It's literally just force. It's not involving any chemicals. So a lot of times we'll see this water, okay? You guys, if you've ever been in a river, you'll notice most of the rocks are smooth in a river. Why? Because they've weathered the rocks away so that they're smooth. The water has weathered those rocks away. If you are in a very windy place, you might see erosion or weathering happening from rocks and wind. Plant roots. If you've ever seen a tree, a big tree next to a driveway or a sidewalk, and you can kind of see the tree's roots is like causing there to be a big crack in the sidewalk or the driveway or causing it to come up. Plant roots are really, really strong, and they can actually break down rocks. So this is a picture. It's kind of tricky to look at, but this is the side of a cliff. And here's a tree growing out of it, and its roots are like sticking out of it. So plant roots are really, really strong, and they can break apart rocks from that. If you've ever driven in the spring, in winter, you know that there are a lot of potholes. So temperature can cause these changes. This is what happens with a pothole. Okay, I hate it when I do this. We get water collecting in a crack, whether it be in the asphalt or in a rock. That water freezes. As it freezes, it expands, and then it creates an even bigger crack or a bigger pothole. And that's why when it thaws out in the summer, we get all of these extra potholes in our roads in Wisconsin. And then the other thing we have is chemical weathering, so actually using chemicals. So a good example of this, any kind of chemical reactions. And there are plants that can release chemicals into the soil or into rocks. As humans, we can create acid rain, which can cause chemical reactions with certain rocks. Acid rain is formed when there's pollution in the air, and then it mixes with the water droplets. So you can see here's an example of acid rain affecting a statue. Okay, so here's the statue before. Oh, this is the before on the right, and then after on the left. Sometimes rocks, particles in rocks react with the air. That would be an example of a chemical reaction. Okay, so these different chemical reactions, whether it's stuff from the air, or from the water, or from organisms, can break down these rocks. A really good example of this is we talked about lichen and moss being the first colonizers, right? The pioneer species in succession. Lichen and moss, lichen, actually secretes chemicals that break down rocks. And this is how they're actually able to make soil. They secrete these chemicals, they can break down that rock, and then it creates the little pieces of rock that are needed for soil. Okay? All right, that's where we're going to stop. If you have a mason jar, bring it to me. You have 15 minutes. I want you to be working on your vocab review. I want the front and back, so the first page, on Friday. Okay? Tomorrow, come hungry, we're making dirt cups.